Let's go through current in series. So number one, what do the symbols in Ohm's law represent? Number two, what is the value of the resistor in that circuit below? So pause, have a go, unpause when you are ready. So V equals IR, the potential difference across components or several components is equal to the current times the resistance. So in this case here, we've got a component, there's a 4.5 voltage across it, or potential difference, and the current running through it is 0.015 amps. We're looking for the resistance of the component. So when you use these formula triangles, you cover up what you're looking for, and it's telling you to do telling you how to use what's left. So we're going to divide the voltage by the current, and that gives us 300 ohms. There's the value of our resistor. So let's just compare this current circuit to another one. If I was to split my resistor up into two separate resistors, so I've got 100 ohms and 200 ohms, and we've still got 0.015 amps running through our circuit, what would be the voltage across each resistor? And once you've worked that out, compare those two circuits. What is the same? What is different? So pause, have a go, unpause when you're ready. So we know the resistance and the current, okay, in that component. So looking at our formula, we know we're looking for the potential difference of the voltage. We need to multiply the current and the resistance, so that gives us 1.5 volts across the 100 ohm resistor, and if we do the same, we're going to end up with 3 volts across the second resistor. When we compare the above circuits, well, we've got the same current. So we've got the same current flowing through one resistor and the same current flowing through both of these resistors. The overall resistance is the same. So there's 300 ohms here, and 100 ohms and 200 ohms in series. That means one after the other would have the same resistance. The overall potential difference is the same. So 1.5 add 3 gives us 4.5 volts. Let's change our scenario slightly. So this time we've got the same potential difference across all three. So how is that going to split if I've got 100 ohms times 3? So one after the other in series. And what would be the current going through each of our resistors? So pause, have a go, unpause when you're ready. Okay, so 4.5 volts. The components all have the same resistance, so there's going to be 1.5 volts across each of our resistors. Couple of key points here. So we know it's 1.5 couple of things here. In a loop, okay, so in series, the current is going to be the same, okay, and that current will be equal to the total potential difference across the components over the total resistance. And the key point here is we're looking at a series situation. So the component series means the components are one following each other, one after the other. So let's just look at our answers. Let's just reflect on these. Here are the three circuits we've looked at. What is the same? Why is the current flowing through all three circuits the same? What have we kept the same in order for that to be true? So pause, write down an answer, unpause when you're ready. So the key thing here is we've got 4.5 volts across in all of these circuits, so 4.5 volts in total in the first circuit, 4.5 volts in total in the second, 4.5 volts total in the last. The total resistance is the same as well, so 300 ohms, 300 ohms, 300 ohms. And because it's a series situation, so in other words, all the components are in the same loop, the current is going to be the same. So the key point here is, so long as our total voltage and our total resistance is the same, the current is going to be the same, and current will stay the same in a series circuit. So here's a slightly different situation. So find the current flowing in the circuit, find the voltage or stroke potential difference across each resistor, pause, have a go, unpause when you're ready. So number one, find the current flowing in the circuit. So the total voltage is 4.5 volts. That's the potential difference being supplied to the circuit. We've got 900 ohms in total, so that's all of the resistances added together. So when we divide those two, and got to divide that way around, we've got 0.005 amps flowing through our circuit. So what that means is we've got 0.005 amps here, we've got 0.005 amps in the middle, and we've got 0.005 amps at the end. Well, we now know the current and the resistance, yeah, for each component, so that tells us we can find our voltage. So for the first component, when we multiply current times resistance, we know there's 2 volts across there. There's going to be 1.5 volts across there, and there's going to be 1 volt at the end. And notice that our potential drops across each component total 4.5 volts, okay, which is the potential drop across the whole lot.